Cassini wasn't just a mission. It was one of the boldest and most poetic journeys humanity ever launched into the cosmos. For 7 years, it drifted through the cold silence of space, crossing over 3.5 billion kilometers to reach one of the most iconic planets in the solar system, Saturn. And when it arrived in 2004, it didn't just observe from a distance. Cassini stayed. It lived with Saturn for over 13 years, orbiting the planet more than 290 times, watching every change, every storm, every flicker of light reflected from its rings. It sent back more than 450,000 images, collected over 600 gigabytes of data, and transmitted discoveries that forever changed how we understand Saturn and its vast system of moons and rings. And then, in 2017, came the final act. Dramatic, deliberate, and unforgettable. Cassini plunged into the planet it had studied for over a decade. As it descended into Saturn's atmosphere, the spacecraft kept transmitting, sending precious scientific data until the very moment it was torn apart by heat and pressure. Why end it this way? Because Saturn has moons, and some of them, like Enceladus and Titan, might host life. Cassini, though carefully sterilized, could still carry contaminants from Earth. If it ever crashed into one of these moons by accident, it could compromise decades of future research. So NASA chose a controlled finale, the grand finale, where science and caution met. Cassini didn't come alone. It carried a second explorer, the Huygens probe, developed by the European Space Agency. In January 2005, Huygens detached from Cassini and descended through the thick orange atmosphere of Titan, Saturn's largest moon. What it found was unlike anything seen before. Titan has rivers, lakes, and even rainfall, but not of water. These liquid bodies are made of methane and ethane, hydrocarbons that are gases on Earth but behave like water in Titan's freezing climate. The probe landed on solid ground and sent back data for over an hour. It revealed erosion patterns, channel systems, and pebble-like formations, all shaped by methane rain, a complete alien hydrological cycle. Meanwhile, Cassini continued orbiting Saturn, providing humanity with its first real look at the true nature of the planet's rings. They're not solid structures, but a delicate, massive collection of icy particles, ranging from dust-sized grains to house-sized chunks. They orbit Saturn independently, and yet form complex, graceful patterns. Spiral waves, braids, gaps, and ringlets shaped by gravitational interactions with tiny moons hidden within them. One of the most surprising discoveries came from Saturn's North Pole, a massive, stable hexagon-shaped jet stream over 30,000 kilometers wide. This geometric weather pattern doesn't change shape. It rotates with the planet and remains perfectly symmetrical. And scientists still don't fully understand why it exists. Cassini also revealed that Saturn's atmosphere is incredibly active. Winds there can reach over 1,800 kilometers per hour. Enormous storms can engulf the entire planet, and cloud patterns shift constantly, driven by dynamics we're only beginning to understand. And then there are the auroras, far brighter and more energetic than Earth's. They are generated by Saturn's magnetic field, the second most powerful in the solar system after Jupiter. This magnetosphere is so vast that it can envelop all of Saturn's major moons. It shapes radiation belts, influences the rings, and reacts to solar wind in complex, unexpected ways. Saturn isn't just a ball of gas with some pretty rings. It's a whole world of interactions, physical, chemical, magnetic, playing out on a scale that challenges our imagination. And Cassini gave us a front-row seat to all of it. The mission didn't just collect data. It redefined our expectations of what a gas giant could be. It showed that Saturn is not a dead, frozen world, but a dynamic system full of surprises, from lightning storms deep within its clouds to possible subsurface oceans on its moons. Cassini made us realize that the story of our solar system is still unfolding. And for the first time, we got to read a chapter that was more mysterious and more beautiful than we ever imagined. Cassini showed us that Saturn was more complex than we ever imagined, but it also reignited interest in a planet that still dominates the solar system in mass, force, and gravitational pull: Jupiter. Jupiter is the giant of our cosmic neighborhood. It has enough mass to hold more than 1/300 Earths inside it. If it had just a little more mass, it might have become a star. But even without generating its own light, Jupiter has a gravitational presence that rules everything around it. It has the most powerful magnetic field in the solar system. So strong, in fact, that it generates permanent auroras at its poles. These auroras, fed by the motion of its moons and the magnetic field itself, can be seen from space, glowing with an intensity that makes Earth's northern lights look like flickering candles. But Jupiter's most famous feature is still that massive storm that's been spinning for at least 350 years, the Great Red Spot. It's so large that 2 Earths could easily fit inside it. Even more incredible, it spins counter to the planet's own rotation. A storm so stable, it broke every weather model scientists had. Now the spot is slowly shrinking, but no one knows why, or if, or when, it will ever vanish. Jupiter keeps its secrets, and some of its greatest secrets come from its moons. The most famous is Europa, a frozen sphere, at least on the surface, but data suggests that beneath its icy crust lies a subsurface ocean with more water than all of Earth's oceans combined. An ocean that's sealed, protected, and warmed by gravitational friction, generated by Europa's orbital dance with Jupiter and its neighboring moons. A dark, warm, mineral-rich environment. If life exists anywhere in our solar system, Europa might be the place. But Europa isn't alone. Ganymede, the largest moon in the solar system, might also have a buried ocean. And Io, another one of Jupiter's moons, is the opposite. A volcanic hellscape, erupting constantly and coated in sulfur. A world of continuous chaos. Jupiter is like a miniature solar system. It has over 90 moons, many of which remain poorly explored. But what we already know is enough to understand. Jupiter is not just a ball of gas. It's a cosmic lab, a giant that nearly became a star, but shaped the solar system anyway. After everything Cassini revealed about Saturn, science turned its eyes back to an even older and more dominant neighbor, Jupiter. Jupiter is the largest planet in the solar system, and that's not just a fun fact. It's a defining force in the history of everything around us. It has more mass than all the other planets combined. Its gravity is so strong that it influences asteroids, comets, and even the behavior of Earth itself. If Jupiter weren't there, our story would be different. It acts as a shield for our planet, capturing or deflecting dangerous objects that could otherwise hit us. But that same gravity can also sling some of those objects our way. It's a strange balance, but a necessary one. Jupiter's atmosphere is something else entirely. It's made mostly of hydrogen and helium, but the storm systems and cloud bands are mind-blowing. It has colorful stripes that move in opposite directions, generating constant turbulence and vortices. The most famous one is the Great Red Spot, a storm that's been raging for over 300 years. It's shrinking, slowly. No one knows why. Jupiter also has lightning bolts 10 times stronger than Earth's, and they appear at altitudes we didn't expect, pointing to atmospheric processes we still don't fully understand. But perhaps the most striking aspect of Jupiter is its magnetosphere. Its magnetic field is colossal. The planet spins fast. A Jovian day is just 10 hours, and that rotation drives a massive internal dynamo. The result? A magnetic bubble so vast it could swallow Earth whole. It also creates brutal radiation, levels that make Jupiter a hostile target for spacecraft. Still, we've sent probes, and we've learned a lot. Beyond the early missions like Pioneer, Voyager, and Galileo, today we have Juno, a spacecraft still orbiting Jupiter and giving us the most detailed look yet. It revealed that Jupiter might have a diffuse core made of heavy elements mixed with gas, something that challenges old theories of how planets form. And then there are the moons. Jupiter has at least 92 natural satellites, and 4 of them are giants: Io, Europa, Ganymede, and Callisto. Io is a volcanic nightmare, the most volcanically active place in the solar system. Constant eruptions, rivers of lava, a surface coated in yellow sulfur. Europa, on the other hand, is a frozen mystery. Its crust is thick ice, but underneath, a global ocean. Dark, deep, and likely warmed by tidal forces. NASA believes that if life exists outside Earth, Europa is one of our best bets to find it. Ganymede, the largest moon in the solar system, has its own magnetic field, a rare trait for a moon. It may also hold an internal ocean. Callisto, ancient and cratered, is like a fossil from the early solar system. These aren't just rocks in orbit, they're worlds. With thin atmospheres, geological activity, hidden oceans, magnetic fields of their own, and all orbiting a planet that nearly became a star. Jupiter is more than a gas giant. It's a whole system, a blueprint of cosmic complexity, and with every new mission, it proves itself stranger, more beautiful, and more important to our own survival. After Uranus, our gaze reaches the farthest giant, Neptune. Neptune is a realm of glacial extremes and storms that defy comprehension. Although it receives only 1% of the sunlight Earth does, it radiates surprising amounts of internal heat, almost twice what it absorbs from the sun. This drives supersonic winds reaching 1,300 mph, the fastest in our solar system. Neptune's most famous feature was the Great Dark Spot, a storm the size of Earth spotted by Voyager 2 in 1989. It vanished and reappeared in different forms, proving that Neptune's weather is ever-changing and unpredictable. Scientists believe that deep currents of salt water under millions of atmospheres of pressure rise and trigger these colossal storms. Neptune also sports faint rings. 5 narrow bands of dark dust and ice, almost invisible, first detected during stellar occultations. Unlike Saturn's bright rings, Neptune's only glow when backlit by the sun, revealing unstable filaments that shift shapes. But the real stars are its moons. Triton, the largest, is a frozen enigma orbiting backwards, evidence it was captured by Neptune's gravity. Beneath its thin nitrogen atmosphere, jets of nitrogen gas erupt in plumes soaring up to 5 miles high, hinting at subsurface activity. Triton is so cold its methane seas can freeze into solid plates. Other moons impress too. Nereid, with its eccentric orbit, may have been flung out by a larger neighbor. Smaller moons like Proteus and Larissa bear heavily cratered surfaces, records of the solar system's early bombardment. Neptune's magnetic field is another puzzle. Tilted nearly 50 degrees off its rotational axis and offset from the planet's center, it creates an asymmetric magnetosphere that dances to the solar wind's tune. This generates auroras flashing far from usual polar regions, scattered across mid-latitudes. Neptune has only been visited by Voyager 2 in 1989, leaving vast gaps in our understanding. That's why a dedicated orbital mission is under study, with probes able to plunge into its atmosphere, map its wind composition, directly measure internal heat output, and analyze the chemistry of supersonic winds. Exploring Neptune means understanding how internal and solar energies compete to govern a planet. It is the remotest laboratory we have for studying exotic storms, metallic hydrogen oceans, and off-axis magnetic systems. And of course, studying Neptune primes us for discovering ice giants around other stars. Exoplanets that, like Neptune, burn from within while dimly glowing under distant suns. If this made you see the universe a little differently, just imagine what's next. Subscribe, turn on the notifications. The next journey might be even more surprising. Here, we don't just talk about space. We go where it starts to make sense.